Hello dear students, so today we are going to start arithmetic progression. This is chapter number 5 in CBSE syllabus NCRT. So as you can see, this is chapter number 5 arithmetic progression. So first of all, going by the definition of arithmetic progression, what it is written over here is that an arithmetic progression is a list of number in which the each term is obtained by adding a fixed number. This is very important. A fixed number to the preceding term except the first term. This is the first term to the first term. Now what does it mean? Suppose there are any set of numbers, few set of numbers I have written it over here. 1, 2, 3, 4. Then there is 100, 70, 40, 10. Then there is minus 3, minus 2, minus 1, 0. And then there is all same numbers are there 3, 3, 3, 3. And then minus 1.0, minus 1.5, minus 2.0, minus 2.5. Similarly, other set of numbers can be 2, 4, 6, 8, 10, and so on. It can go on, and then it can be minus 5, 0, plus 5, and then 10 and 15, and similarly it can be 6, 9, 12, 15. So you can see there's one common thing in all these numbers are that common thing is in all these set of numbers there is one common thing. What is that common thing in all these set of numbers? For example, if we add plus 2 into, it will become 4, and then if we again add plus 2, it will become 8, and then if we again add plus 2 to 6, it will become 8, and then if we again add plus 2 to 8, it will become 10. Okay, then coming to this one, if we add plus 5 to minus 5, it will become 0. Then we are adding again plus 5, then we are adding again plus 5, and then we are adding again plus 5. So we are obtaining a list of numbers in which a fixed number is added to the preceding term. These all are terms 2, 4, 6, 8, 10. These all are terms. And then if we see again here plus 3 is added. We have added 3 to 6, it has become 9. Then we have added 3 to 9, it has become 12. And then plus 3. Okay, and then you can see it over here, we have added plus 1 to all. 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, 4 plus 1, it will be 5. All those not done over here. Then what we have done over here, we have added minus 30. If we add 100 plus minus 30, it will become 70. It will become 70. Okay, then again we have added minus 30 to 70, it has become 40. Then again we have added minus 40, minus 30 to 40, it has become 10. So we are adding minus 30. Here we are adding, anyone of you can guess it, what we are adding over here? We are adding plus 1. See, minus 3 plus 1 will be minus 2. Minus 2 plus 1 will be minus 1. Minus 1 plus 1 will be 0. And then it will go on. Here what we are adding? Here we are adding 0. Nothing. Or we can say 0. Here what we are adding? We are adding zero point 0.5. Minus 0.5. So all the things which is common over in all these things are that we are adding one common term and the next term is obtained. Here we are in every number we are adding plus 1. Here in every number we are adding minus 30. Here in every number we are adding plus 1. Here in every number we are adding 0. We are adding minus 1.5. We are adding 2. A fixed number we are adding plus 5, and then we are adding plus 3. So now we are coming again to the definition. An arithmetic production is a list of number. You can see these all are list of number. You can see these all are list of number in which a term is obtained. For example, 2 is obtained by what? By adding plus 1. Then 3 is obtained by adding plus 1. You can see it over here. This 4 is obtained by adding plus 2. 6 is obtained by adding plus 2. 8 is obtained by adding plus 2. In which a fixed number is obtained by adding a fixed number. A fixed number should be always be added. It is not that if you are adding plus 2 over here, and then you are adding plus 3 over here, and then you are adding plus 4 over here, and then you are adding plus 5 over here, then this is not the case. This will not be an AP. So you have to have add a fixed number to every term, and then you will get the next term. So this is the definition of AP. For example, again I am writing few examples. Although I have written many examples, it can be, let us say, 8, 16, 24, 32, 40. Then I am writing 8, 10, 14, 20, 24. And then we up now see a fixed number is added plus 8. Let me change the color, it's not much visible. And then again we have added plus 8, and then again we have added plus 8, and then again we have added plus 8 to obtain the next number. So this is an AP. This qualifies as AP. This series upper one, this one qualifies as AP. But if you see in this set of numbers, plus 2 is added, then here plus 4 is added, then here 6 is added, then here again 4 is added. So this doesn't qualifies to be an AP. So I hope that what is AP and what not is AP. So now we have learned that what is AP. For example, the very basic AP is written on the screen is just 2, 4, 6, 8, 10. And why it is an AP? Because we have added a fixed number, that is 2, then plus 2, then plus 2, and then plus 2. We added a fixed number, and that is why it is an AP. Now again, let's see, we have to understand a few basic things. What is A and what is B? A is the first term of an AP, and B is the common difference of an AP. A is the first term of an AP and D is the common difference of an AP. Let us explain this via example. Let us again same example, 2, 4, 6 and 10. We all know now that this is an AP. Now I will not tell you why this is an AP. Now let's see the what is the first term you can see in this AP. You all can very easily say that, sir, the first term in this I can see is 2. So here the first term is 2. So the first term of an AP, that is A, we denoted by A, and this is 2. And what is the common difference in this? The common difference is also 2, because we are adding plus 2 continuously to each preceding term to get the next term. Now let's say again there is an AP example. We can take 20, 30, 40, 60. Then again we take another example is that 45, 50, 55, 60, 65. Now what is the first term of both the AP. You can very easily say that the first term is 20 over here, and then first term is 45 over here. So here the A is 20, and then in this AP the A is 45. And what is the common difference, sir? The common difference is 10. The common difference is 5 over here. So now we have learned that what is A and what is D. The A is the first term of an AP, the A is the first term of an AP, the A is the first term of an AP, and D is the common difference of an AP. And D is the common difference of an AP. Okay. Now there is again very interesting thing which I am going to tell you is that the fixed number, that is the common difference, the fixed number, that is the common difference, it can be positive, negative and 0. For example, D can be positive also, D can be negative also, and D can be 0 also. I will explain you how. I will explain you with an example. Let's see how first D can be positive. First we'll see how D can be positive. So let's take an example of 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So here you all can tell me very easily that here, sir, here the D is 2. Let's take another example, 10, 20, 30, 40. Here also D is 10. So here also and here also, in this both case D is positive. Now let's see when D is negative. When D is negative. Let's take an example of an AP. If we reverse this AP only, 2, 4, 6, 8, 10, if we reverse this AP, where the first term becomes 10, 8, 6, 4, 2. Now here the D is minus 2. How D is minus 2? Because we are adding plus minus 2 to each term to get the another term. Let me explain you how. If we add minus 2 to 10, we get 8. We have got 8. And then if we add minus 2 to 8, we get 6. We get 6. If we add plus 2 to minus 2, if we add minus 2 to 6, we get 4. And if we add minus 2 to plus 4, we get 2. And this way it can go on also. So here you can say that the common difference is minus 2. Another example we can take is that 40, 35, 30, 25. Here also D is minus 5. Always remember, if the AP is decreasing, if the consecutive term of an AP is decreasing, for example in this case, the consecutive term of an AP is decreasing. You can see the consecutive term is decreasing. The first term was 40, then it has become 35, then again it is decreased, it has become 30, then again it has decreased, it has become 20. So the consecutive term is decreasing, so D will always be negative in such APs where the consecutive term is decreasing. Let's notice in this case also the consecutive term is decreasing, 10, 8, 6, 4, 2. Then again it is, here D will be negative. So in any AP where the consecutive terms are decreasing, in that AP the D will be negative. And if in any AP the consecutive term is increasing, in that case D will be positive. Now let's see when D is 0. because we have said that D can be positive also, D can be negative also, and D can be 0 also. It's very common, very easy. 3, 3, 3, 3, 3. If anyone asks you if this is an AP, you can will say yes, this is an AP. Many students get confused, so this is not an AP, but this is an AP. And what is the common difference? There the common difference is 0. If anyone asks you if this is an AP, minus 5, minus 5, minus 5, minus 5, we will say yes, this is an AP. What is the common difference? The common difference is 0. So if in any AP the common difference is 0, then in that AP each term, each term, each term will be same. So this way AP in AP D can be positive also, negative also, and 0 also.